Hello, today we will get the Laplace of t times e raised to at. So to get the Laplace, we will use the formula Laplace of f of t is equal to integration of e raised to negative st times f of t dt. So we will substitute Laplace of t times e raised to at is equal to integration of e negative st, our f of t, te of at, dt from 0 up to positive infinity. So, it is approximately equal to e negative s of t times t e raised to at dt from 0 up to a. So, our a is also equal to infinity. We just substitute a so that we can assume that it is a very large number. So, we have our e raised to negative st and e raised to at. So, we will use the power, we will use the rule of exponents, which is the numbers with the same base. When multiplied, we will add. So, we will apply e, a minus s, they have the same t times t dt from 0 up to limit a. So, we will use integration by parts to solve this problem. U times v minus integration of v du. So, in this equation, our u is t, our du is dt, our v dv is 1 over a minus s e negative times raised to a minus s times t dt. That means that our v is equal to 1 over a minus s times e raised to a minus s times t. We will substitute the equation. Our u is t, our v is 1 over a minus s e raised to a minus s times t, have a limit of a from 0 minus integration of our v 1 over a minus s times e negative s raised to a minus s times t, our du dt. So, we will solve first that t 1 over a minus s e negative s plus a times t with the limit of a from 0. So this equation, it will become a a1 over a minus s e times a minus s times a minus 0 1 over a minus s times e raised to a minus s 0. Now we will notice that our equation here is multiplied to 0. That means that our equation is equal to 0. Now if we analyze, our 1 will be divided by e raised to a minus s times a. So we assume that a is a very large number. If we divide our 1 with a, it will be divided by very, very small parts, which is approximately equal to 0. That means that our equation is equal to 0. We will come back here. Negative integral of 1 over a minus s e a minus s of t dt from 0 up to a. So, we can extract the negative 1 over a minus s, copy the equation, from 0 up to a. Now we will continue here. The integral of e raised to a minus s, that will be equal to 1 over a minus s e raised to a minus s t, limit of a from 0. So, we will first solve this equation. 1 over a minus s e a minus s times a minus 1 over a minus s times e raised to a minus s times 0. So, we will use the similar technique here, which is e raised to a negative s times a. If we divide our 1 with a very large number, it will approximately be equal to 0. That's why we will assume that our equation is equals to 0. Now here, our e raised to a minus s times 0, e times 0 is equal to 1, because any number that is raised to 0 is equal to 1. That means that we will be remaining negative 1 over a minus s. The whole equation will be negative 1 over a minus s times negative 1 over a minus s. So, to simplify this equation, we have negative 1 over negative s plus a and negative 1 over negative s plus a. We can cancel the negative sign. The equation will be equal to 1 over s plus a squared. So, our Laplace of t e raised to at, the Laplace of t e raised to at is equal to 1 over s plus a.